Folks, welcome back. We're here once again continuing our conversation with our friend Ollowain, who's working with a Gigabyte Brix board like this one that he's having some trouble with and needed some help with his troubleshooting. Now before we get started, I want to mention that with my sincerest apologies, I gave some wrong information in the last video. So before we get any further than this, I want to correct that information. So what I said was, we have a series of VRMs, or voltage regulation modules, also called buck converters, along this sort of edge of the board, and I gave the wrong function for several of them. So let's just zoom in, and I'll point to each one, and I'm going to tell you what the actual correct function is, because I've had a chance to go back and look that up. So let's go ahead and zoom in here. Zoom in a little further. There we go. Okay, now that we're zoomed in, we can see that on this side of the board we have at least 6 VRMs. We've got 1, 2, 3 right here, 4, 5, and 6. And we know that because we've got an IC with our FETs and a coil and some capacitors on this side. So these two are related to the CPU in some way. I think this one is actually the core and this one may be the GPU. I don't actually know. But these two are related to the CPU, and we know that because they're connected to our main sophisticated buck converter controller over here. This one, I believe, is what's called VCC I/O, which is, it's sort of like the memory controller. It's common to adjust it in competitive overclocking, but basically we just need that to work. Then this one here, I said was the memory controller, and that's wrong. This is actually VCC SA, or the system agent, which is sort of a board-wide logic that controls some of the low-level functions of the system. So once again, we just need that to work. It's not really related to the compute logic in any way. But it is important we need it to work. And I think this is the circuit that Ollowain is having trouble with. This one I guessed correctly, and this is the 5-volt VRM that powers our USB ports. And this one right here is actually our memory controller. And we know that because, let me zoom you back out so you can see here. If we flip the board over, we can see we've actually got 1.35 volt DDR3L memory on this board. And I should have maybe done that before. While we've got the board on this side, I should also mention that our 3.3 volt controller is this guy right here. See that? We've got an IC and a choke. So let's flip this back over. You'll notice that it's on now. It's not exactly working, but the board is not completely dead. Let me just show you, for the record, that that is in fact our memory rail. So if we take our meter in DC mode, probe right there, we'll get 1.35 volts. Right? So, while we've got this on this side, we'll also take a look at our other rails. This one should be 1.2. 1.0. Is this, maybe this one is 1.2? 1.1. Okay. So there you go. 1.15-ish. 1.0. 5. 1.35. So there you go. These two rails are still dead. I still have to figure those out on mine. He says, okay, finally got to it. The memory VRM coil shows about 1 ohm resistance to ground. When I measured voltages, all VRMs showed 0 voltage while measuring on the same points you measured the resistance. Don't know if that's the right point. I think not, because I got already a good 3.3 volt output at the power button. I think I have to measure it at the output of the FETs, but I wasn't able to get my hands on a safety pin yet. He's talking about how I used a safety pin to make the end of the probe finer. Anyways, I guess I have to further troubleshoot the memory VRM now. I randomly checked caps for their resistance, but I can't distinguish if they are resistors or caps, so I have no idea how to proceed from here. Another question. Why did you measure the resistance of the VRM at the coil pads and not somewhere else? Just because they're big and easy to spot, or is there something more to it? Again, thanks a lot for your help. It's very much appreciated. Well, Ollowain, you actually hit the nail on the head there. The reason I like to use the coil output to measure the voltage is it's a big pad that's easy to stab with the multimeter probes without risking stabbing something else by accident. Also, it's important to measure at the output side of the coil because you're actually going to have AC voltage on the input side. So if we look here, if we were to measure this side of this choke, what we've got going in there is very, very rapidly alternating 19 volts and 0, 19 volts and 0, 19 volts and 0, at a ratio of about like 5% of the time. We've got 19 volts, and 95% of the time we'd have 0. So you can imagine if you made a graph, it would be big spikes. That's what you would get if you measured here, and your multimeter may not like that. So what we do is we measure on the output side, because the function of the coil is to smooth that spikes out into a nice smooth flow, and that's what it does. So, 1, we've got a big pad there that's easy to stab, and 2, the coil smooths the alternating spikes out, and that's what you need to measure. Otherwise, you'd get something that's like alternating 19 volts on your meter, and the meter wouldn't be happy about it. Mine actually has a warning that it generates if I do that when it's in DC mode. All right, moving on to Ollowain's real question. He's figured out that he has a short to ground on the output side of one of his VRMs. What does he do now to find the source of his short to ground? Well, there are a number of things that he can do, and it sounds like he's actually started trying one of them, which is to simply remove suspect components and see if that's the cause of your problem. I would urge caution doing that, simply because 1, you can damage them when you remove them, and 2, you then have to put them back, and the soldering them back on involves a risk of damaging them or getting them not quite on right or losing them, or any number of things can happen when you start removing stuff from the board. So if you don't have any other options, just removing them and seeing if that fixes your problem is a good one to try. The other obvious thing is a visual inspection. So if you know which components are part of your circuit, if you simply look at them, sometimes you can tell that one of them is damaged. That's actually the most successful thing in my experience, is just looking at the board, and often you figure it out just by looking. But failing those two things, there are some other options that you can try. I have some other videos about this, and I actually have to get to work at my real job here, so I'm not going to demonstrate it now. But one of the best things you can do is pass a current through the circuit and inspect the board for places that get hot. So you can do that in a number of ways. One of which is that you simply touch stuff with your fingers while you're passing the current through it and see if anything is hot enough to be noticeably different. Another way is to use isopropyl alcohol. Now, this is the cheap kind that you can get from a drugstore, and this bottle costs like $1. But you can get 99% pure isopropyl alcohol from Amazon as lab supplies, and that works even better. But the trick is, you put a little bit of it in the area that you think your short might be, and you pass current through the circuit. And you simply look for places where the alcohol either evaporates quickly or actually boils or catches fire. It does help to have a fire extinguisher handy for this, because that stuff is flammable. And once you find a place where the alcohol boils, then you know that that's where all of your energy is going. And it may or may not be the source of your short circuit, but it's a good place to start. And that's probably what I would do next if removing suspect components didn't help. So what I would do in Ollowain's case is I would solder the positive wire onto our terminal here, because I think this is the VRM he's troubleshooting, and the negative terminal here, and connect the wires up to a bench power supply and pass 1 volt, which is our operating voltage for that circuit, through the wires, and see what gets warm. If you have a 0 ohm short to ground, something should get warm. However, now I want to go to a little diagram, and we'll look at what could potentially be the problem. Here we have an idealized diagram of a buck converter, similar to the one that Ollowain is working on. We've got our high voltage DC input from here. We've got our high side MOSFET and our low side MOSFET. We've got a control IC, and we've got the inductor and the load. I labeled this memory, but just imagine that says load. Whatever it is you're powering goes right there. So, if Ollowain is measuring from here, like I showed it before, let's look at all the places that could potentially be a short to ground if you had a failure. So, one path is through your load. So, if you had, say this is the CPU, and the CPU melts, and now you've got just a wire that goes through the silicon, that's one possible path. Same thing with your capacitors here. These are used to stabilize the voltage on our VRM output. If one of these failed and created a short, you could have a short through there. You can also have a short back through the inductor, through the low side MOSFET, if this failed, to ground. Or, most controllers actually have I've got it here. This path. Most controllers actually have a voltage sense on the output, where if the controller fails and becomes a wire, you can have a short to ground. And one more option, you can actually have the board itself melt, in which case you get something where you've got the voltage output in one layer and the ground plane in another, and the layer isolating them melts, and now you've got them touching, and you've got effectively a wire that connects your output from your VRM to ground. So any one of those things could potentially be the source of this problem. Unfortunately, you have to do this basically by elimination. Alright, so what should Ollowain do next? Well, as we talked about before, the most precise test you can do to find where your problem is the current test. So you would attach the wire from your bench power supply here and the negative wire here, and you pass 1 volt through it, and you just see what gets hot and replace that component. Failing that, or if you don't have a bench power supply, the next thing I would try is remove your controller MOSFET IC right there, assuming that this is the VRM troubleshooting. Basically, that's going to be 75% of the components of a normal buck converter that you might have fail anyway. That circuit, that IC is an alpha and omega Z1268Q. I'll put a link to the datasheet down in the description. You said you were having some trouble finding it. So if that doesn't work, chances are your problem is either the board itself or the CPU, and those aren't really repairable things in practical terms. Sometimes you can grind out a short from the board, but on a board this small, I'd be afraid to do that because there's almost certainly logic lines basically everywhere, I would think. So, as always, I hope this helped you out, and let me know what you find, and I'll see you in the next one.